cloud of gas many times larger than the solar system. And
The
small
hellish
knots
solar
of material
corona
would
rages
gradually
at millions
coalesce
of
in this
degrees.
very large
For
cloud.
centuries,
About
scientists
5
have been
billion years
baffled
ago,
how
some
anything
10 billion
so
years
far
after
from
the
the
Big
Big
Bang
Bang
that
scientists
still
believe
burn so
kick-started our
hot.
universe. This cloud
Recently,
started
as
to
improved
collapse
satellites
under the pull
offered a
of
closer
gravity.
view of the
Our solar system
surface.
probably arose
Clues
from
began
one
to
such knot of
emerge.
self-gravitating
Below the
gas
corona,
that pulled
the
itself
sun's
together
surface is
and
literally
gradually
boiling.
spun itself up as it
The
pulled
reason
in, like a
is
skater
that the
pulling her
entire
arms
surface
in
of the
during a
sun
spin.
is covered with convection
until
cells.
the
Hot
star
material
and
from
the various
inside of the
planets
sun
coalesced around it.
rises up through,
Ultimately,
reaches
when
the
the star
surface,
was dense enough,
cools off by
it would have
glowing,
turned on
giving off sunlight,
fusion,
and then
started
sinks
glowing,
back down,
giving off sunlight.
Each bubble of material that comes
Why
up
do
is about the size
scientists
of
believe
Texas.
the sun
It
was born
spreads out
from the
across the
ashes of a
surface, cools off, and
supernova?
sinks down in
The
5
evidence
minutes.
lies beneath our
So
feet.
that's a tremendously
Complex, heavy
violent
elements
process.
like the uranium
That's
we
happening
mine
in
from the
literally
Earth to fuel
almost
our
a
nuclear
million
power
places over the
plants
entire
could not
surface
have
of
been
the sun, all
forged
the
in the
time,
sun.
around the clock,
There was simply
24/7.
not enough heat in a star that size to create elements. This
any
boiling
heavier
isn't
than
only
iron.
violent, it's also extremely loud. Heavy elements like uranium can only
sun
be
is a
created in
tremendously
a
loud
catastrophic
place.
cosmic explosion. Earth
You can
and the
imagine
other planets in the
covering the
solar
entire
system
surface of the
formed
sun
out of the same
with
knot
speakers
of
being
gas
driven
that
as hard
produced
as the
sun.
loudest rock concert
In this
you've ever been to.
process, the sun
That-
hoarded 99% of the mass. This means it's the biggest object in our celestial neighborhood with the strongest gravitational pull. That's why everything else revolves around it. Of all the planets, Earth earned a privileged place in relation to the sun. If we were closer in, our oceans would boil away and the ground would be hot enough to melt lead. If we were farther out, our planet would be a frozen wasteland.
Sort of like Goldilocks and the Three Bears. Not too hot, not too cold, it's just right. Here we are at about 93 million miles away from the sun, and we're happy to be here. We're lucky to be here. And in some sense, we're here because it's the right circumstance for us to be here.
Earth may be in just the right place in the solar system, but we're also close enough to the sun to be a target of its fury.
How do you win over fans? You give them something they love, something no one else can,
And we're happy
something
to be
they
here.
can't
We're lucky
get
to be
enough
here.
of.
We're here because
And then
it's the right circumstance.
you
for us
give
to
them
be here.
more.
Earth may be in just the
Hurry
right
in to see
place
why
in the
Ram
solar
has the
system,
most loyal
but we're
half-ton
also
pickup
close
owners
enough to the
during the
sun
Ram
to
Summer
be a
Clearance
target
event.
of its fury.
How do you win over fans?
Thousands of mammoth explosions rock our sun every
You
year.
give them something they love, no one else can.
You might expect this explosive force to come from nuclear reactions in the core. But in reality, what drives all outbursts of solar violence is magnetism. Since Earth rotates as a solid, our magnetic field is simple. We have two poles, north and south. This is what makes a compass so useful for finding your way around the planet. But imagine if instead of two poles, you had 1 to 10 million. This is what happens on the sun. The sun's magnetic field is a tangled web because even though it's held together by gravity, the plasma doesn't rotate evenly. Plasma at the equator rotates once every 25 Earth days, while plasma at the poles takes roughly 35 days to circle once.
The sun has what we call differential rotation. You have all of this plasma that is really turning and churning, and that causes magnetic field lines to become twisted and intertwined and mixed up.
Although magnetic field lines are invisible, we know they exist on the sun by looking at features called coronal loops and prominences rising up into the solar atmosphere. Just as metal shavings line up in the presence of a simple magnet, these loops of plasma perfectly outline the magnetic structures that support them from below. These plasma arches are so tall and wide that you could slide a planet as big as Jupiter right through them. Sometimes magnetic fields can twist plasma in the sun's atmosphere into majestic helical shapes called flux ropes.
Magnetic flux rope is sort of like a slinky. The magnetic field line is wrapped around many times in a helical structure. And when you have highly twisted magnetic field lines, it carries a lot of stored free magnetic energy. And sometimes it will even kink in on itself, which gives it even more stored magnetic free energy.
These plasma prominences can last for weeks or months, but eventually the stored up energy has to be released, and the mass is flung off into space.
The
Where the
magnetic field
sun's
line is wrapped
magnetic
around many
field is
times
at
in a
its
helical
most
structure.
twisted and complex,
when you have
heat bubbling
highly
up from below is capped, and the material is cooled by as much as 1,000 degrees. What results are relatively dark blemishes on the solar surface called sunspots. Sunspots are only dark in relation to the bright material around them. If you could somehow suspend one alone up in space, it would shine 10 times brighter than the full moon. These apparently tiny blemishes are actually plasma craters the size of the entire Earth. Galileo was one of the first modern scientists to observe sunspots. Using a telescope, he projected an image of the sun onto paper and traced it. He realized that the blemishes were moving across the face of the star, which was the first indication that the sun rotated. Not only does the sun rotate, but sunspots themselves can actually spin like hurricanes on the solar surface. And when they do, their magnetic field lines become extremely twisted. Twisted magnetic field lines mean more energy, and more energy means the potential for huge eruptions.
Think of a rubber band as a magnetic field line. If you twist it, and you twist it enough, it's going to have all that energy, and when you let it go, it's going to release. If you just take an untwisted rubber band and release it, it's not going to fly.
When a sunspot unleashes its magnetic energy, what results are the most colossal explosions in the solar system: solar flares. A single flare releases as much as 1 billion megatons of energy, the combined power of 1 million volcanic eruptions on Earth.
They appear as these very bright regions, and they're so bright because the temperature is so high, on the order of 10 million degrees. And they can last for hours, but the energy is massive.
The whole explosion is equivalent to millions of nuclear bombs leaving the surface of the sun all at once.
Solar flares don't just explode out into space. They also funnel high-energy particles down to a layer of the sun called the chromosphere, where they quickly transfer their energy like a cue ball striking the rack in a game of billiards.
So the cue ball acts like one of these very high energetic particles coming from the flare region. The cue ball smacks very quickly into the 8-ball rack. And once it impacts that head ball, it's going to transfer that energy to the balls behind it, and then they will all fly out because the energy is transferred to all of them.
If a large flare shoots enough high-energy particles at once, strange things start to happen. This is actual footage of a sunquake.
In 1998, there was a solar flare up in the corona that was so powerful that the material flying down toward the surface of the sun actually slapped the surface and caused ripples to spread out from there.
While they may look like ripples on a pond, these are actually waves 2 miles high, traveling at a maximum velocity of 250,000 miles per hour. The 1998 sunquake would have measured an 11.3 on the Richter scale, more than 1 million times stronger than the 1989 earthquake that shook San Francisco. In order to shake the surface of the sun that much, the solar flare had to release a colossal amount of energy.
It turns out it's almost the same amount of energy as if you covered the entire landmass of the Earth with dynamite, about a yard thick, and set it all off at once. So these explosions are not small.
Earthquakes aren't the only natural disasters with equivalents on the sun. A flare can also kick off a solar tsunami, as waves of plasma in the sun's atmosphere rocket out at 700,000 miles per hour, spreading around the entire face of the star in a matter of hours. While sunquakes and solar tsunamis pose no danger to Earth, the violent action of a flare frequently triggers dangerous eruptions called coronal mass ejections, or CMEs. In a CME, energy from a flare flings a blob of highly charged radioactive plasma out of the solar atmosphere.
Coronal mass ejection